In this example, we're going to solve an equation that involves two radical expressions. If g of t equals the square root of 2t plus 7 minus the square root of t plus 15, find any t for which g of t equals negative 1. First thing we're going to do is replace g of t with negative 1. When you're dealing with an equation that involves two radicals, you want to get one radical on each side of the equation. So let's move the t plus 15 by adding it to both sides. So we have the square root of t plus 15 minus 1 equals the square root of 2t plus 7. Now what we're going to do is we're going to eliminate at least one of the radical signs by squaring both sides. Now when we square the left-hand side, we'll have to use FOIL to multiply these out. So let me show you what this looks like. We would have the first, since we're multiplying the square root of t plus 15 times the square root of t plus 15, we would have just t plus 15. The outer, the inner, and the last. So notice that we have two of the same in the middle terms. So let's combine our like terms. We would have t minus 2 on the square root of t plus 15. Then we can combine 15 and 1 to give me plus 16. So let's see where this takes us. So here's my simplified expression. Notice on the right-hand side, when we squared that 2t plus 7 all under the radical just goes away, leaving me with only 2t plus 7. Now we want to get everything that's not a radical on one side and isolate the radical t plus 15. So let's subtract t and subtract 16 from both sides. At this point we have two options. We could divide both sides by 2, or we could leave it over there. Leaving it over on the left-hand side, whenever we do square both sides, it's not too difficult to do that. So I'm actually going to leave it over there because otherwise we'll have a fraction on the right side. So I'm going to square both sides now to eliminate that last radical. On the left-hand side, we'll have 4, because that's 2 squared, times t plus 15. On the right side, we need to FOIL that out. When we FOIL it, here's what we find. Now let's distribute this 4. Now let's get everything on one side and setting it equal to 0. Now we'll factor the right-hand side. The right-hand side factors into t minus 21, t minus 1. This means we have two possibilities. From this expression, we find that t could be 21. From this one, we find that t could be 1. Now what we want to do is we want to go back and plug in these two numbers into our original equation to see if one or both of them are correct. So let's plug in t equals to 21 first. In our first expression, we would get the square root of 49. In the second expression, the square root of 36. 7 minus 6 does not equal -1. So 21 cannot be a solution. Now let's check our solution of 1. We have the square root of 9 minus the square root of 16. This is 3 minus 4. -1 does equal -1. Therefore, our solution is t equals to 1.